Hello everybody. Once again I am here with you for the another one session which is related with the elasticity and this property already all of you have studied at the 12th standard, but in detail we will see what exactly the related parameters to the elasticity is to be there. First of all, to understand the elasticity, it is basically what is mean by to be as an elasticity. A simple example or is nothing but to be this rubber band. When the deforming forces you are applying, it changes the dimensions, and after removing of these deforming forces regain its original position. This rubber band regain its original position. So this is what the property of this material is to be there, that to regain its original condition or the position on the removal of deforming forces. Now what exactly the deforming forces, that is to be external forces, are to be there, and this is what the property of the particularly we can say elasticity is to be there. Now the deforming forces are nothing but to be here to be as an external forces are to be there. Here on this rubber band I am applying the deforming forces, but that I am stretching in opposite direction, but when I am removing these forces it's regaining its original position, and that is what called to be as an elasticity. Now the body which can be recovered completely to their its original position, that is what the perfectly elastic bodies, and the bodies which do not reform its original position, and that is the glass or some sort of steel iron is to be there, then such type of the bodies are called to be as in plastic bodies, where the deforming force or the so after removal of this deforming force, the body is not material is not coming back to this original condition or not recover their original condition, and such type of the bodies are called to be as in plastic bodies are to be there. And uh, bodies of the substance which have the same property throughout the material, means this rubber band having the same property throughout the material at the end in all direction, or with this particular rubber band at any stage where I am applying this force deforming force, the same result I have. And that's why the such type of the bodies which are showing all the same property at all the points are to be there, and such type of the bodies or such type of the materials are nothing but to be called homogeneous. Secondly, bodies are the substances which have different properties at different points, and that's what the such type of the materials or the bodies are nothing but to be called heterogeneous. असे मटेरियल जे की थ्रूआउट त्याच्या एंड ऑफ दिस मटेरियल म्हणजे थ्रूआउट द एंडपर्यंत एक सारखीच प्रॉपर्टी डिफाईन करते, आणि अशा प्रकारची जी काही रबर बँड जसं की आहे, हे थ्रूआउट द मटेरियल कुठल्याही पार्टवर जर अप्लाय केला मी फोर्स, तर आय हॅव द सेम रिझल्ट. आणि अशा प्रकारच्या मटेरियल्सला किंवा सबस्टन्सला आपण होमोजिनियस म्हणतो. पण जर समजा बॉडीज ऑर द सबस्टन्सेस विच आर हॅव्हिंग डिफरंट प्रॉपर्टीज, वेगवेगळ्या प्रॉपर्टीज ॲट वेगवेगळ्या पॉईंट्सवर जर दाखवत असेल, तर तशा प्रकारच्या मटेरियलला आपण हेट्रोजिनियस असे म्हणतो. as far as the metals are to be as an crystalline in the structure, and isotropic as for the elastic behavior is concerned. Now external force acting on a body changes the form or the dimensions of the body, and such dimensions of the bodies and called as a deforming forces, that is already we are known. The restoring or the recovering force per unit area is nothing but to be a stress, that is to be the restoring force per unit area is nothing but to be stress is to be there. म्हणजे जर समजा या रबर बँडवर स्ट्रेस, व्हेन आय एम एक्सटर्नल फोर्स आय एम अप्लाइंग, डिफॉर्मिंग फोर्स आय एम अप्लाइंग दी ॲट द सेम टाईम, मी ज्यावेळेस ह्याच्यावर अप्लाय करतोय डिफॉर्मिंग फोर्स, याला दूर नेण्याचा प्रयत्न करतोय, तेव्हा रबर बँडमधून एक इंटरनल एनर्जी जी काही किंवा इंटरनल जे काही एक फोर्स काम करायले, ते काय करायले आतमध्ये ओढायले, not to change its original position. And the such type of the restoring or recovering force per unit area set up inside a body is called to be as an stress, to regain its original position. And if the force be inclined to the surface and its components are to be particularly to the surface measured per unit area, it is also to be as a normal stress is to be there. But the important factor is nothing but to be the components acting along the surface area. It is called to be as an tangential or shearing stress is to be there. And as far as the dimensions are going to be concerned of the stress or the pressure or the coefficient of elasticity is nothing but to be the similar one, m l minus 1 t2 is to be there. And if some another properties if we wants to learn, that is to be as an strain is to be there, which is also to be the change produced in the dimensions of the body under a system of the forces or the couples in the equilibrium is called to be as an uh, basically your strain is to be there. And no doubt the change in the dimensions or the change in the shape of the particular body with respect to the applied stress, again we can say it is called to be as an your strain is to be there. And as the strain is dimensionless quantity, because change in the length upon change original length or the change in the anything divided by the original whatever be the its length or the particularly we can say the area or whatever be there, that always to be as an strain is particularly called to be as an dimensionless, because it is only a change in the length upon the original length type of the things are to be there. Similar quantities in the same unit is to be there, and that's why it is having no unit. Again, for the perfectly elastic bodies, the strain is always same for the given stress. Perfectly elastic bodies, the strain is always same for given stress. जेवढं काही मी स्ट्रेस अप्लाय केले त्याच्या अलॉंग द वॉट एव्हर बी दिस stress is to be there, it is with respect to whatever be the strain change will be occurring, it is due to the respective with the stress is to be there. किती प्रमाणात मी फोर्स अप्लाय करायलो, that is to be the on the body, that amount of the change or the strain is going to be occurring on the body, and that's why it is to be like this. And strain vanishes completely when the deforming force is removable. No doubt the strain will be vanishing as the deforming force is over, and in such a way the maintaining the strain is going to be constant. And in general way, the whatever strain is going to be the constant, or it is called to be as a modulus of rigidity, modulus of elasticity is to be there. And the ratio stress upon strain is nothing but to be a modulus, and there are three types of the modulus that we will see in the next part also. Now here the important factor we are going to learn today with related to this topic or the elasticity is nothing but to be twisting couple on a cylinder or a wire. For that we have to consider a wire and clamped at one end, that is like this. This is one hollow cylinder, it is like this hollow cylinder is to be there, and clamped at one end fixed point is to be there. So the wire is just like this. If a cylinder or a wire, either it is called to be a cylinder or a wire, clamped at one end and twisted at the other end through an angle theta about its axis, then due to this twisting, the elasticity of the material and the cylinder of the wire, the restoring couple along this is set up in it, and whatever be the equal and opposite to the twisting couple is to be there. And in this case, how it is to be going to be related, for that simply either you are using the wire or any rod or any hollow cylinder is to be there. So in this case, the basically the whatever be the if a cylinder or the wire are going to be clamped at one end, that means to be it is fixed at one end. Suppose here it is to be the case where this is what the cylinder is to be there hollow, and which is going to be clamped at the one end, that is the top part. And if I am going to be applying some deforming force at this stage, that is what the case where it is to be as an the such type of the restoring couple will be going to be generated, set up in it, and it is equal and opposite to the whatever be the twisting couple is to be there. And here it is to be, if suppose I am applying one one side is going to be clamped and other side is going to be twisted, then definitely the whatever be the stress is going to be there, it is observed by this rod or the hollow cylinder or a wire is to be there. Now in this case, the important factor is to be how much amount of the stress or the how to get the calculate the twisting couple, means the force on this particular wire or the cylinder is to be there. Now this is what the simply diagrammatically it is shown how the changes are going to be occurring as far as the diagrammatically it is shown. I already told you this is what the hollow side, where it is going to be the hollow side will be looks like, or cylinder will be looks like this. This is what the shape where it is in the B diagram 1B, the whatever be the look will be like this, where it is to be very important factor, the radius is nothing but to be r, r theta is sorry r is to be there. And another one factor, when the same cylinder if you looks through this way, it will looks like this. And now whatever be the clamping is to be there at the A side, if I am removing this, it will become to be as an plain paper, or that is what it is. And when I am folding it in this fashion, it will become to be as a cylinder, and it is in the form of cylinder, or again it is to be as an hollow cylinder is to be likewise this end. So whatever be the I am twist is going to be applying at the other end, that makes a difference in this twisting. म्हणजे आता जर समजा मी काय केलं की एका साईडला मी फिक्स केले क्लॅम्पकडे फिक्स्ड केलेलं आहे, आणि दुसऱ्या साईडने जर फोर्स अप्लाय करायलो, तर समहाऊ काय होते, देर विल बी एक्सटेन्शन ॲट दिस अदर एंड इज टू बी. म्हणजे काय की जर समजा मी एका साईडला त्या सिलेंडरला फिक्स केलं आणि दुसऱ्या साईडने जर ट्विस्टिंग और डिफॉर्मिंग फोर्स अप्लाय करायलो, तर त्याची पोझिशन थोड्याफार प्रमाणात चेंज होते. दॅट इज द वॉट एवर द फोर्स इज गोइंग टू बी अप्लाइड ॲट दॅट स्टेज, द डिफॉर्मिंग रिस्टोरिंग फोर्स इज गोइंग टू बी कमिंग इन टू ॲक्ट. मी ज्यावेळेस त्याला असा ट्विस्ट करायचा प्रयत्न करायलो, तेव्हा ते आतमधून पुन्हा पहिलीच्या जागेवर जाण्यासाठी प्रयत्न करायला किंवा फोर्स करायला तसं. And that is nothing but to be your elasticity is going to be working. Now due to that, what is going to be happening, upper point will be same A, lower side will be B, but when I am twisting it, it will give me new dimension or one another additional point, that is to be as an P dash or whatever extended part is to be there. And that is what the, if suppose A side is upper side, this is what the B, then when you are extending it, it will become B dash is to be there. And that's what it is shown here in this second diagram. The whatever be the length of the cylinder is nothing but to be small l. It is shown here with this case, that is what showing the length of the your cylinder. No doubt when I am twisting at the lower end in this direction, या डायरेक्शन मध्ये मी जेव्हा त्याला ट्विस्ट केलं, अप्पर साइड इज गोइंग टू बी फिक्स, and at that stage this B point will become to be as an B dash, and that's what we can say there is a twisting. But here the job is not over. Again the whatever be the twist is to be there, इथं जेवढ्या प्रमाणात मी ट्विस्ट लावणार आहे तेवढ्या प्रमाणात इथं अँगल त्याचं तिथं राहणार आहे. जितकं मोठा ट्विस्ट राहील तेवढं हे अँगल हे त्याचं जास्त राहील. No doubt same length will be there and it will form a new angle, that is nothing but to be given here with this case, where it is to be, if you look at this diagram, it is giving you the 3 points B, A, B dash is to be there. So this is what the angle it is to be there, and when I am removing it, it will give me this position like a paper, and B will be here. Suppose this one is the A point, this will B will become to be as an B will become to be as an B dash, C will become to be as an C dash is to be there, D is as it is. So this is what the setup is going to be working. And when the same cylinder is going to be, if you look in this direction, it will looks like this. This is what the cylinder is to be. First diagram, it looks like to be first one. So as this type of the things, and here the angle made by this B, A, B dash is nothing but to be the phi, and the angle made by this child, this small end, this is end part at the cross sectional part, it is to be there. It is having the same, when extension is to be this way, it is also giving me the, this is supposed to be the R, and in that case the B dash will be here, it is nothing but to be given with the angle, that is the phi angle, or here it is to be phi, then it is to be as an theta is to be there. So at the both the end, the twisting or the couple is going to be giving us one change in the angle, that is either phi or the theta is to be there. So this case is to be up to this much, and as the whatever the part is to be there, I already told you, and regarding this the same thing is to be copied here, that is hollow cylinder where to be cut along the AB and flattened out, it will be from the other one, or basically when if you look at this case where it is to be as a very important factor, to the same thing is going to be here explained. To calculate the couple or the twist, basically what we have to do is basically two things are to be there. द ट्विस्टिंग, आता ह्या साईडला मी फिक्स केलेलं आहे, अनदर साईडला मी ट्विस्ट करायला, तर ट्विस्ट करताना हा जो बी पॉईंट आहे, बी विल बिकम टू बी डॅश, थोडंसं पुढे जाईल, पण त्याच वेळेस ह्या साईडला जी सिलेंडरचा ही जी पोझिशन आहे त्यामध्ये सुद्धा काय होते, पोझिशन ऑफ द दिस theta angle is going to be also giving me to be as an B dash new position is to be there. So the AB will be the line, here it is to be as an at this stage, and cylinder has the thickness of radius x and the radial thickness is to be as an dx, that is to be there, and let AB be a line parallel to this axis before the cylinder is going to be twisted, and after twisting point B shifted to B dash in both way, इथून B shift होऊन B dash ला जाईल, तसंच इथं सुद्धा B dash ला जाईल, so making at angle theta and the phi at this stage, and after twisting point B shifted to B dash and AB makes to be as an position, that is AB dash is to be there, मग नवीन पॉईंट जो मला मिळणार आहे AB dash मिळणार आहे, आणि before the twisting is going to be if before twisting, if the hollows of cylinder were to be cut along the AB flattened out, it will form the regular plate ABCD, but after the extension or the twisting of the form, the shape AB dash C dash D as shown in the third diagram, when it is to be as an like this will become A, B, it will be B dash, C will become here C dash, and D is to be there. Why it is to be there? Because due to twisting or the applied couple, this position is going to be changing, of the B will become to be B dash and C will become to be as an C dash, and that's why the newly formed area A, B dash, C dash, D is to be there. Now the angle through which the hollow cylinder is going to be sheared. First thing is to be BAB dash is nothing but to be here. When it is twisting at this stage, ह्या स्टेज मधून मी जेव्हा ह्याला ट्विस्ट करायलो त्यावेळेस the angle is to be as an made here BAB dash. If you look at again here, it is to be as an here it is to be BAB dash is to be there. So look at this case where it is to be as an BAB dash is to be there. This is what here it is to B. Here it is B A इथं A and B dash is to be there. So this is here the two things are going to be happening at the same twist. For the same twist, here it is to be the angle that is phi. It is to be phi angle, it is made along the AB line, and here at the same stage this angle is made to be as an theta is to be there with the same thing, that is BOB dash is to be there. So for a single twist, the two angles, twisting angles we are getting at along the AB line or along the radius internal line is to be there. So this is what the basically the change is going to be occurring for the same twist or the couple. And here it is to be the case where we stopped, that is to be A B dash C dash D will be the newly formed area or the position, and the angle through which this hollow cylinder is sheared, that is BAB dash is equal to phi. That is first one, and another one is to be, and the another one is so that in this case, so BAB dash is nothing but to be phi. So इथं जी अँगल हे चेंज व्हायले, हे इथून थोडं पुढे गेल्यावर हे जे अँगल तयार व्हायले, BAB dash will be nothing but to be giving me phi will be there. And the same at this stage, आता ह्या स्टेजला जे काय मला म्हणजे along this directionच B dash will now to be as an L phi is to be there. How it is to be B dash is to be L phi, because it is right angle triangle, and according to that the sine or the cos of this theta is nothing but to be B dash is equal to L phi is to be there. And in the same way, along this way, the BB dash will be x theta, because here the angle twist is going to be theta is to be there. मग ह्या ठिकाणी ह्याची रेडियस किती आहे x आहे, आणि theta is nothing but to be angle, and that's why BB dash is equal to x theta is to be there. And if you look at in both the cases, for the BB dash along the AB direction, it will give me L phi, and BB dash along this direction I am getting the relation, that is x theta is to be there. So again here in this case, if suppose I want to change the particularly case, where I can write phi is equal to, म्हणून राईट हँड साईड जर दोन्ही ह्याच्यात जर तुम्ही बघताल तर लेफ्ट हँड साईड BB dash सेम आहेत, मग राईट हँड साईड सुद्धा L phi इज इक्वल टू एक्स थिटा असं मला म्हणता येते. मग ह्या जर समजा इज इक्वल टू एक्स थिटा असं जर म्हणलं तर त्या केसमध्ये मला phi इज इक्वल टू एक्स थिटा बाय L हा जो इकडचा L आहे इकडं जर आला तर डिवायडेड बाय L असं मला लिहिता येते. So this is what the newly formed relation that is to be for the phi angle, or basically phi will be maximum where x is the greatest. हे जे अँगल आहे हे जितकं जास्त मी ट्विस्ट देईल त्यानुसार हे अँगल जास्त आहे, आणि त्यानुसारच हा जो x आहे is going to be greater in the same way. Now the maximum strain is on outermost, and the least on the innermost. Here is the form or the confirm the shearing stress is not as an uniform, and eta is nothing but to be shearing stress upon shearing strain, that is f upon phi is to be there. And in this case f is equal to n eta, basically it is given n eta is equal to shearing stress upon shearing angle, we can say is nothing but to be f upon phi is to be there. and the f in that case I can write is equal to eta phi is equal to eta is nothing but to be eta x theta by L is to be there. So this is what the case where the this f is going to be obtained, and here this cylinder having the face area of the hollow cylinder, it is nothing but to म्हणजे परिघेचा it is twice pi x dx is to be there. Another one x format, it is having one disk having the thickness dx is to be there. So in that case the whatever be the face area is nothing but to be twice pi x dx is to be there. And now the total shearing stress this on the area, it is nothing but to be whatever be the value, it is to be here, it is here twice pi x dx is to be the value, where it is becoming now, it will become twice pi x dx eta into theta by L is to be there. So this is what the total shear now it is going to be formed, and this is what twice pi x dx eta into theta L is to be there. Now if you look at carefully what is to be as an related to remaining parts, twice pi as it is x as a eta dx theta by I, आणि इथं eta x तर x स्क्वेअर इज टू बी there. बऱ्यापैकी बऱ्याच पार्टला हे एकरूप आहे. नाव हिअर द another part where it is a moment of the force about the axis. हे जे सेंटरला ॲक्सिस आहे ह्याचा या सिलेंडरचं, त्याच्या अलॉंग द ॲक्सिस what amount of the force is going to be working, and that's why whatever be the radius is going to be x considered, that you have to multiply it. म्हणून it is twice pi eta x square dx again it is x by L, and that will give me simply twice pi eta theta x into x square, that is the x cube is to be there, d theta by dt is to be. Now in the same way the integrating this between the limit x to r, 0 to r, sorry, that is variation in this radius will be from 0 to r, and that's why we are going to integrating this relation. And if you integrate this, total twisting couple on the cylinder is nothing but to be given 0 to r म्हणजे काय, total radius of this cylinder is to be this much of amount r, and therefore 0 to integration 0 to r, and twice pi eta x cube theta by L dx is to be there. मग आता twice pi eta theta by L, all these factors are constant, this and this parts are constant, remaining is only integration 0 to r x cube dx, that is to be there. And here in this case again if we put these values then same आता जसं मी सांगितलं होतं twice pi eta theta by L integration 0 to r x cube dx is to be there. And if we put these values, twice pi eta theta by L x raised to 4 integration 0 to r x cube dx, that will be becoming to be as an x4 by 4, and that's why twice pi eta theta by L into x raised to 4 by 4. And if we solve this बे दोन्ही 4, it will become simply to be बे एक बे बे दोन्ही 4. आणि या केसमध्ये आता the new relation will be formed, and that new relation will be likewise here it is to be as an pi eta theta r raised to 4. So if the theta radian is going to be 1, then twisting couple per unit twist of a cylinder is nothing but to be C is equal to, that's why here it is to be the final relation, C is equal to twice pi C is equal to pi eta r raised to 4 divided by 2l is to be there. So this is what the case where the twisting couple you have to use, and using the twisting couple you have to find out the required parameters are to be there. So this is all about the twisting couple on a cylinder, and thank you for joining this session. Next part in the next unit or the next video is to be there. Till then, take care. Bye bye.